Last year, I made a small solar panel system. It is only used to charge gadgets that uses USB, which is a 5 volts output. This year, I plan to make another solar panel system to power all of the lightings in our house, just the lights. In this way, we can pay less in our electricity bill. Not a really big savings, but at least we have lights during blackouts. See? So let's get started. I use this 30-watt solar panel and connect it to the step-down converter with adjustable current and voltage. First off, let's talk about the solar panel. According to my research, a solar panel will produce a certain amount of power depending on the current and its voltage. You can see this in a typical IV curve. I is for current and V is for voltage. We observe that as these variables changes, the power also changes. But in a certain point here, we see that it results the highest power. We can call this the maximum power point. But how can we operate in this maximum power point? We can do this by adding this circuit. It monitors the voltage of the solar panel, making sure it will not go down below the preset limit. I adjust the minimum voltage. As I adjust, I also measure the current in the output. Finally, in the end, I found the right voltage, which gives the highest current and means more power. The right voltage is 15.0 volts. This is the lithium-ion battery pack that I made from cheap power banks. Basically, this is the circuitry. I paralleled these pairs and connected it to a battery management system. What's the purpose of the BMS, or battery management system? BMS protect the lithium-ion cells from overcharge, over-discharge, and overcurrent. So everything is safe. And because of that, it can last a lot longer. By the way, I get that BMS from the power bank itself. I added 2 more sets, then connected them in series. And we now have a 12.6 volts battery pack with a capacity of roughly 4000 mAh. Let's go back here. I adjust the output to 12.6 volts, which the batteries need to be fully charged, then connected it to the pack. I adjust the maximum current to 1.2 amps, and now each cell will receive roughly 0.6 amps. We have just stored the energy from the solar panel. Alright, what about the bulbs? What kind of bulbs are we gonna use? For this project, we will use LED bulbs because it's already available and it consumes very less power. In our house, we already use them and it's rated at 240 volts AC. But how can we power that lamp? We only have 12.6 volts. So what I've done was literally crack it open, did some reverse engineering and trace the circuit, which look like this. It is just a capacitive power supply to step down the AC to DC that goes to the LEDs, which are connected in series. I plug the circuit to the mains and measure the voltage across each LED, and the voltage is roughly 3.1 volts. Because there are 14 LEDs in series, it will need 43.4 volts. To lower this voltage, I hack and remove the other circuitry. I only connect 5 in series, so I have 2 sets of this and connected them in parallel. Because we have 5 LEDs in series, we only need 15.5 volts. I just leave the other 4 and we'll just add the locking LED next time. I tested the circuit and it works. As you can see, it is safe to touch. You might say, where did I get that 15.5 volts? That came from the step-up converter that obviously steps up the 12.6 volts to 15.5 volts efficiently. After hacking all our bulbs, I turn off the breaker to avoid, I reverse engineer the circuitry in our house, which takes a lot of time. Instead of installing new set of wires for the bulbs, I just reuse its old wires. In this kind of activity, you should know exactly what you are doing, or else. I finally connected all the connections, and it works. Boom, it's working. We now have free energy to power our lights. In part 2, I will show the approximate calculations like how long the battery will last, calculating the converter's efficiency, and other upgrades. If you like this video, don't forget to hit like, share, and subscribe. That's all. Thanks for the view. Be innovative.